Okay, welcome back, Algebrists. Today is February 12, and we are continuing in 5.2, and we will finish 5.2 today. So yesterday, we started with just some basic property stuff that we can work with, and we worked out some of these rules. Just checking, and we'll just go hands up for this, which I don't always do. Anybody feel confident that you can tell me how the power of a power works? Liam, what you got? Deal becomes what? A to the x times y. So if it's a power to a power, we just wind up multiplying. This is arguably going to be the most important property out of these that we're going to see right now. Now, whether or not that's really true, I don't know. But I know that this is the one that I use the most. Gosh, what about the power of a product? Anybody feel confident without just shouting it out? Angel, what you think? A to the x times b to the x. I wouldn't call this distribution because there's no like addition or subtraction to really distribute, but it does attach to everything. It works kind of like distribution, but I wouldn't call it that. Okay, anybody disagree with this? Okay, Naomi, what about the power of a quotient? A to the x over b to the x. Okay, this one is the one that we may talk about, but we'll just see. How many of you guys remember ever dealing with negative exponents? Okay, fractions. Anybody in here have no idea how to deal with a negative exponent? I don't believe you. So it is. Do you know why? Okay, here's my challenge for you guys. You have 30 seconds, so you got to do it quick. Talk with your neighbors. If you know that the rule, and I'll even give us the rule, a to the negative x, what does this become? 1 over a to the x. And I'm going to make this an and instead, because we want to make sure we can go the other direction also. And we also need to make sure that we have, if something is like 1 over a to the negative x, what happens there? So you want me to write a1? ax, like this? Oh, a to the x, okay. And I'm being snarky, I know what you mean. I just want to make sure the language is clear. Okay, here's the challenge for you. 30 seconds with what I've drawn here. You know what? We'll go 60 seconds to make sure we can get some better explanations. Why does this rule work? Convince me that this is a rule rather than because Holloway said it is or because Miss Osman or Miss Jarvis, whomever. It doesn't matter. Why does that rule work? I want justification. Use numbers. Those numbers, preferably. What do you guys think? I have no idea. So check this out. Without just doing the calculation in your head, can you guys see what's written in red there? Is it too small? The 2 to the stuff? Can everybody see the 2 to the 4, 2 to the 3? Okay, if I wanted 2 to the 5th, can you do it really quickly and easily without doing 2 times 2 times 2 times 2 times 2? How? Mark, you said yes. You just did this times 2 one more time, right? Okay, what if I go the other direction? What if I knew that 2 to the 4th was 16 and I wanted 2 to the 3rd? Instead of multiplying, what would I do? I would divide, right? Play with that. 30 seconds. You'll see how this works out. What do you guys think? If I asked you, and you're going to hear the same thing in a minute, so I apologize. If I asked you to get to 2 to the 5th with what's written on the board there, but don't do 2 times 2 times 2 times 2, could you get there really easily from 2 to the 4th? How would you get 2 to the 5th super easily? Yeah, just multiply by 2, right? And we could just do it again and again. What if I gave you 2 to the 4th and I asked you, how do you get 2 to the 3rd easily without doing 2 times 2 times 2? Yeah, if I know 2 to the 4th is 16, how do I go the other direction to get to 2 to the 3rd? Ooh, so I don't love that one. What was yours? Multiplying will get me to 2 to the 5th, though, wouldn't it? There we go. That's what I'm looking for. Okay. Checking this out. I've had a couple groups. Anybody that I didn't speak to directly have a good explanation for this? Okay. So there's an awesome way to do this. If I asked you guys, can everybody see what's written here? Okay. If I asked you guys to give me 2 to the 5th, but I don't want you to just look at the whiteboard and I don't want you to do 2 times 2 times 2 times 2 times 2 times 2, is there an easier, faster way to get 2 to the 5th? How? we literally just, every time if we're going down this list, we multiply it by 2, right? So times 2 this way, times 2, and we can always get to the next power. What if I wanted to go the exact opposite direction? We would divide by 2, and we see it works nicely. If I take 32 divided by 2, I get to 16. Let's start here. 2 to the 1 is 2. What if I went back 1 and I divided by 2? Weird, this tablet is trying to die, or this pen. It'd be a 1. And all of a sudden we have a good justification why 2 to the 0 is 1. What if we went again? It'd be 1 over 2. Now, it feels cumbersome, and it is to write it this way, but do you guys agree that that is the same thing as saying 1 over 2 to the 1? If I went one more time and I divided by 2, or multiplied by 1/2, which is the same thing, I would get 1/4. Everybody okay with that? Is 1/4 nice? Is there a better way that we could write 4? 2 to the what? Squared. And I see exactly the rule that you guys told me happening here. We can see it does work. It follows a pattern. It's nice and easy. Okay, for these, we're going to use every single one of these rules, and we're going to start combining this with the fact that we can rewrite nth roots, or any root for that matter, as an exponent. And we're going to see that maybe, just maybe, there's a really nice way that's going to be a bit quicker than what we've been doing. So we're going to use all of those properties, and we're just going to jump right into some examples, and we'll start with some chill ones. First, all I want us to do is rewrite in the simplest, I should have just said simplify, but that's okay. Simplest form. And Miss Sweet, random question for you. Do you have the other pen on you? Can I see if it's just this pen that's malfunctioning? Because that would be awesome if all my smart boards weren't dying. Thank you so much. All right, so we're going to rewrite in simplest form. Now, just to make sure we can all agree what this means, couple things that we require with simplest form. We need to make sure that there are no negative exponents. Okay, that's one step. Can't have any negative exponents if we're going to be completely simplified. Beyond that, we need to make sure that all, what does this symbol mean if I write this fancy Q? Rational, which means what? What's a ratio? A fraction. So all fractional or rational exponents are simplified. And beyond that, we'll require that they're in the numerator. And if you think back to geometry, were you ever allowed to keep a square root in the bottom of a fraction? I don't think so. And we had to fix it somehow. That's called rationalizing. We'll review that stuff. Only other thing that I care about right now is that there's no common variables. I'm going to use vars for variables in numerator and denominator. So if we have an x in the numerator, we can't end with an x in the denominator. Sorry. Now, we'll talk about, like, there's some weird little language things, but no common variables in numerator and denominator. And I'm going to not really change it, but I do dislike the language that I've chosen. I'm going to cross out variables with, I'm not erasing it because I want to make sure we can see where this change has happened. I think we should say factors. And there's a reason that I'm doing that, and it's pretty specific, but we'll make sure that we do an example where this is clear. Okay, these are the rules, just that. So we're going to rewrite the following in simplest form. Just checking to see if I'm going too fast with writing. What's up? I'm going to use factors. We can keep it variables, but there's a better way to talk about it, and factors is the better language. Okay, so here we go. All I want us to simplify down as much as possible is the following lovely expression. We have 3 divided by 32 to the 2/5, and all of this is being raised to the power of 1/2. Okay, There are a ton of options for us here. And I know that it can be stressful if there's not like a clear set or step that we go through, but there's not. There's various ways that we can do this. This one, maybe we're going to be kind of pigeonholed into all doing the same thing initially, but it won't always happen. So do you guys still have access in your notes? I can't see it on mine, but you have all those exponent properties that we just wrote. Okay, so let's make sense of some of this then. Right now, there's a few different things we could do. Anybody have a good first thought on what you might try to do? Which of these exponent properties should we try to use? I see power of a quotient. So immediately, I'm going to annotate these more than I typically do. I'm just going to say quotient is the rule that I'm using. Now, it's implied, I hope, that this is the power of a quotient property that we have right above. What would this turn to if we change it to the power of a quotient? 3 to the 1/2 over, and this is going to get ugly because this whole thing is going to be raised to the 1/2, right? So what should I put around it? Good. If I don't put parentheses around it, do you guys agree that this is crazy misleading? The exasperated sigh would seemingly agree with that. So yeah, 100%. Let's put parentheses around it. 1/2. Awesome. We've done the very first property. Are we done? Why aren't we done, Angel? Oh, we have a power to a power in the denominator. Okay, well, let's clean this up then. We'll go from this step, and I'll switch colors every step. And I'm going to work, I know it's weird, but I'm going to work this way so that we can see the whole example on one screen for me. Okay, so if I do the power of a power, what happens to the top part? Nothing. Okay, deal. 3 to the 1/2 over 32 to the 2, or 32 to the what does it become? One more time. Somebody said it. I heard it. It was right. 2/10. Now, I am going to write something else here because there's something nicer that we could write here. Angel said it already. 2/10 is fine, but what's wrong with it? What annoys you, I hope? 2/10 is not simplified. So if you want a whole new line, you can. I'm just going to call this, I lied, I'm going to keep it here. And you can just change it if you want. I'm going to write a whole new line. 32 to the what power then? 1/5. Are we done? Why not? Cannot read minds this morning. Nor lips, apparently, because I saw you said something, Michael, but I did not understand what it was. Okay. Are you sure? All right, anyway, regardless, what do we do next? Why aren't we done? So I'm going to do two things. If you didn't hear Mark said we need to solve. We're trying to simplify. Solve is very specific to if we're trying to get like x equals something. I know you're on the right track, but we're going to try to make sure the language is as clear as possible. We do need to keep going. And somebody else over here said something. I don't know who it was. Quotient. You want to do quotient rule? Didn't we already do that? The other quotient rule. What's the other quotient rule? So that works really, really well if, what do you notice about these two things that we're having raised to the power? They're the same. Are they the same in our example? No, I like that thought, though. That's a good thought. This is the part that's kind of bugging me. 32 to the 1/5 is kind of ugly. If only I knew what 32 were, and I love where I see Lily's eyes looking. I'm not looking at where she was looking. Holy cow, 32 is 2 to the 5th. Well, this is a place where you're naturally going to skip a step if you can see what's about to happen. If I replace 32 with 2 to the 5th, and I'm raising it to the 1/5, and here all of a sudden is where these exponents get really powerful. Do you guys love doing fifth roots of stuff? Probably not. Now, if they're really nice, it's convenient, but I could rewrite this as the fifth root of 32, and I could do that whole process that we did the last couple of days, right? Or is there another property that works out here? What is it? It's a power to a power. What do I get if I do 5 times 1/5? 1, which means if we use power to a power of a power one more time, what's in the numerator? 3 to the 1/2 still over 2 to the what? 2 to the 1. I'm just going to write 2. And now we're going to look. Do I have any negative exponents? Do I have the same base, which is a number that the exponents are connected to, showing up more than once? No, I have a 2 and a 3. Do I have any non-simplified exponents anywhere? I don't think so, right? Everything's simplified as much as I can. If you want to go one more step because you feel like this is not satisfactory, you are welcome to change this to the square root of 3 over 2. I prefer this version. This is equally good. It's crazy hard. Let's do another one. Is this one that we're doing together? Or are you guys going to try one on your own? Okay, before we do that, any questions? All questions. What questions do you have regarding problem A? It makes dollars. Sorry, go ahead. What happens with these power to a power? You're looking here, right? Before that. Here to here? Okay, which part? What is 2/10? Yeah, what goes into both of them? So, I mean, you gave me the answer at the end. If I have 2 over 10, do you agree that simplifies down to 1 over 5? That's it. Yeah, I just changed 2/10 to 1/5. Okay, let's try another one. About the same, or do you want a little uglier? A little uglier. All right. So B. Let's go. We're going to shoot for like 90 seconds because we're not talking this one through. I would encourage annotate. Entirely up to you since they're your notes. So let's see here. I want you guys to clean up for me if possible. 2a to the 1/3. Lost my spot, sorry. Times, in parentheses, we have a times b to the 1/2. A times b to the 1/2. And then that lovely thing gets raised to the power of 2/3. Okay, there is a 12-6 curve staring down the plate at you right now. Be careful, talk it out. I'm not going to tell you what I'm warning you about, but there is something that there's a mistake I'm expecting. Okay, let's go like 2 minutes. Let's see where it's at. Talk it out. Try something. As we're looking at this, there's more than one way to do this. Ronathan, what did you do first? Okay, he sees power of a power, and I like that. Ronaldo's looking at this power to this power. But we have to be careful. There's something else happening. It's not just b to the 1/2 raised to a power. What's happening inside these parentheses? A is also being raised. So we have two rules happening simultaneously. We have power to power happening. And then I'm going to write this on 2 lines. We also have the power of a product happening at the same time. Now, these properties you will naturally just get memorized by working with. But remember, if you don't memorize them, and I don't want you to just commit them to memory by just reciting over and over, be able to work out those simple rules that we did with the 2's yesterday. So one step away, we get 2a to the 1/3. And how do we do the power of a product? Good. This 2/3 goes on each piece, right? So I get an a to the 2/3, and I get a b to the, is it 1/3? How do we get 1/3? 2/6 becomes 1/3. Okay, awesome. We just did both those rules. Now, at this point, I've included the parentheses and I've kept them. Do they really do anything for me, though? Like, they're just telling me to multiply, right? But if I don't put them there, what am I still being told to do? Okay, Seabass. So I bet we're about to get there. Yes is the short answer. Okay, so you guys weren't able to follow what he said, but I'll tell you he was 100% right. Now, good job, Seabass. We can clean up the language a little bit. But if these parentheses don't really mean anything, and this is purely optional, but do you agree that this is just 2a to the 1/3 times a to the 2/3 times b to the 1/3? Okay, like it's the same thing. Whether you, I wouldn't normally write this. Do we have any of the same bases? Now, just to make sure we're clear here, the base is the thing that's being raised to a power. I have the same base here, and they're multiplying. What does the rule tell us to do if it's a product with exponents? So let's do that. This is still 2 times, and let's just see. Can I just write what these add to, or do you want me to write out the addition? What's 1/3 plus 2/3? Do I need, try again. 1. Do you want me to write 1? Did I lose you, Seabass? No? Okay. So we have 2a to the 1 times what? B to the 1/3. Awesome. One last step. This is just a little extension on this. I want you to write this instead of rational exponents right now, your answer. Write it in radical form. So right now there's no root symbol, whether it's square root or not, doesn't matter. There's no radical in this answer. I want you to rewrite this answer with the radical. You're going to rewrite that same answer, but somewhere in your answer, this needs to show up. My radical symbol. Somewhere.
Why don't you distribute multiply the a to 1/3 with b to 1/3?
Because, check it out. Love it. 100%. Because if I try to do, I'm going to use nicer numbers. If I try to do the 8 to the 1/3, how do I? I'm okay with your explanation rather than trying to come up with a nice example that doesn't add anything. They have to be the same. And if you notice here, bases match.
Oh.
And we have to have those bases match.
Yeah,
yep. Like it's a reasonable thought. And we'll get to adding and subtracting square roots here soon. Okay. What changes? What is underneath the radical? What do you want me to write? Anybody feel confident? Michael. Love it. 2a times the cubed root of b is the alternative. Now, I didn't notice anybody as I was coming around. What I was expecting people to mistakenly do was connect that 1/3 to the 2 also. That is the most common mistake. Parentheses matter big time. Now, we have PEMDAS in the back of our minds as we're working these, and we need to have PEMDAS in the back of our minds while we're working these. We follow through, and we make it nice. Okay, should we bump it up a little bit? Good. So from here, we're obviously kind of blending the world between exponents and square roots and stuff, which makes sense because they're inverses of one another. It's just like we blend the world of addition and subtraction or multiplication and division. It's the same thing, just with bigger operations. One of the things that we're going to start practicing with more and more, and it's going to look very familiar to stuff that you did in geometry, is we are going to start working on writing in what we call our reduced radical form, which maybe we've already kind of alluded to this a little bit. The reduced radical form. So really quick and easy definition, and then we'll do a couple examples of this. So for reduced radical form, we're going to say that this thing is simply written, and I want to think of the nicest way to say this. We'll just say simplified, no radicals in denominator, which is the same statement we made above, but we didn't write it exactly like this. No radicals in denominator, and powers simplified. At the very start of today's lesson, we started saying simplify. I told you what it meant to be simplified. One of them is repeated but worded differently. What did we say was needed for simplifying earlier in today? I think it was the first example we did. 3 characteristics that we identified. No negative exponents, deal, which, is that written up here? So let me phrase that question better. I do not physically write word for word no negative exponents here, right? But do I say the same thing? no radicals in the denominator is the same as having no fractions in the denominator, right? Like, same thing. So we see really the same simplification. We just have the specific name for it. So let's do a fun one together. This example, all we're trying to do is rewrite reduced form. And I'm just going to say rewrite reduced to save a little bit of time, with the implication being that it's this reduced radical form is what we're talking about. Okay, let's get ugly. Example A. Yep, love it. I want us to deal with the fourth root. It's a fraction, just so you guys know, of 81 x cubed y. And we're going to have this divided by the fourth root of 32. Okay, it feels like a different problem. It's not. Would we rather work with radicals or exponents? Exponents, is this a together problem or with your table mates, and I'll work it ahead up here? Table mates, cool. I'm going to give you guys a head start. I'll come work it. I'm not going to just wait for everybody to be done and then work the whole problem. I'm going to start working it while you guys are still going, and we'll discuss if we need to. But try it with your neighbors. I like the suggestion. Somebody said, let's change this to exponents instead. That's what I would do. 100%. I would change this to exponents right off the bat instead of radicals. 2 minutes, try it out. I'll start working it here in just a moment. I'm in class. So my first thought is let's get rid of the fourth powers, right? Like or the fourth roots, I'm sorry. They're ugly to deal with. This is a little bit nicer. Now, no offense, but I think I'm a little bit better at math than you guys, so I'm going to see some stuff faster than you do, I think. I right away recognize 81 as a fourth power. And on the board, you probably will too. Instead of writing 81, what could I possibly replace it with? 3 to the fourth. So do you guys agree that this still says the same thing as the previous line? That's 81 x cubed y. I've just written 81 as 3 to the fourth power. Is there a convenient way that we could write 32, possibly? You don't think so? Is 30? Oh, it doesn't show up on that list. Man, maybe there's some numbers that we should have more than the list on the board. What's 2 to the fifth? Okay. Am I allowed to do that? I think so. Does that still say 32? Yeah. So the rule comes from the fact that 32 is 2 to the fifth. I think you were kidding, but I'm going to give an answer. Okay. At this point, I'm just working through making stuff nice. What should I do with this 1/4? Who does it connect to? Everybody. Cool. Let's do that. So this becomes a power to a power. What happens? What's 3 to the 4 to the 1/4? Try it again. 3 to the 4 to the 1/4. What happens with these exponents? And we get 3 to the 1. Okay. X to the what power now? 3/4. And y to what power? 1/4. Over, how do we clean up the bottom? 2 to the 5/4. And it's kind of ugly for now. Now, with this, is this bigger than 1 right now? And by that, I mean this specific exponent. Okay, I really wanted to give you homework tonight. It looks like it's going to have to be tomorrow, but I'm going to make one more comment before you guys pack up. Do you guys agree that this is the fourth root of 2 to the fifth? And can I write 2 to the fifth as this if I want? There's a reason I would do this. Your homework tonight is to continue and finish this problem. I will be checking at the start of class tomorrow to ensure that you finish the problem. Cool. Later, Raiders.